of fire. No matter how the heat, different temperatures. No matter where he's from, hot to cold, how done. Radiation heat, it goes through the skies. Convection through his eyes is where the heat supplies. Don't get too close. You go by. Convection heat goes by. Three ways heat is supplied. Out on the sand that's warm. The light is out. All your tools get burned. So the heat in place will be passed away to the molecules of the nearby space. All this is conduction, works well in solids, though this heat will come through liquids, that is true. No matter how the heat, different temperatures meet, no matter where he's from, hot to cold, how it's done. Radiation heat, it goes through the skies, convection through his eyes, is where the heat supplies. Don't get too close, you don't fly. Convection heat goes by, three ways heat is supplied. They say when heat will make the fluids near it change, the liquids and gases make convection currents. The air it changes right from source of heat or light. It's moving to and fro, bringing heat with it now. Radiation heat, it goes through the skies. Convection through its rise is where the heat supplies. Don't get too close, you touch the fire. Convection heat goes by, three ways heat is supplied.
All right, friends. I hope you enjoyed that heat transfer song. And I was loving seeing some of the ways that you all were transferring or found ways that heat was being transferred through conduction in your house yesterday. Ooh, I love that, Sergio. So I know that some of you maybe weren't at home yesterday. Maybe you were at a learning center of some sort. But remember to think outside the box. A lot of people were looking for examples of things cooking. I saw cooking pancakes. I saw cooking eggs. I saw a lot of examples of cooking. But remember that conduction is heat transfer through touch. Okay? So when you're cooking something in the microwave, we're going to talk about that today. That item is actually being heated through waves. That's why it's called a microwave. So, any of you who used the microwave as an example yesterday, that's actually an example of radiation. So I'm going to send that back to you, and you can change the annotation on that picture and upload it for today's assignment, because today you're going to be giving me an example of convection and an example of radiation. So I'm going to get two pictures from you today. Let's see. Samantha, yes, she gave me the example of hot hand yesterday. So I appreciated that. That was different. Also, there were a couple people who were like transferring heat from like a cold bottle of water. The heat was being transferred from their hands to the water bottle because they noticed that their hands got cold. So yes, they're touching the water bottle. It conducts the heat energy from your hand to the water bottle. If you touch the bulb, then yes, anything that you can touch and the heat be transferred, then that is conduction or contuction. Now, today we're going to be talking about two other examples, but before we get into that, I just want to remind you very quickly that we do have some of you who are going to be star testing after science today, so please make sure that you stick around if your name is on this chart. Scan really quickly to see if your name is on this chart. If you are listed, you will need to stay after science today. All right, moving on. So today we're going to talk about how convection and radiation are at work in the world around you. But before we do that, there was one example of conduction that I didn't think about yesterday. I kept trying to get a student to think of this example because they were at dinner and didn't have a stove or something, and that's where mine kept going. But guys, think about it. Whenever you sit down on something, when you touch it, it is cool. It is cooler than your body. So when you sit down on said object, sitting, your body heat is transferred from your body to the seat that you're sitting on. This is an example of conduction. Okay? Also, it could be as simple as like your clothes. You could have taken a picture of yourself because you know when you put your clothes on, when they come out of the closet, they're a little bit cooler, but after they've been on your body for a while, they start to be warmer because the clothes are touching your body and the heat is being transferred. Now, your clothes are also an insulator, but we're going to talk about that next. All right, but today we're going to be talking about radiation and convection, the last two types of heat transfer. Let's go. So the first one is radiation. So you guys are going to remember radiation is heat being transferred through rays, like the sun's rays, or waves, like microwave. So radiation is through rays or waves. Alrighty. Oh, yes, nah, sitting in a chair. Okay. So there we go. One important thing to remember when we're talking about radiation. In order for heat to be transferred through radiation, they are not touching. So if you tell me you go outside and your hair got hot from the sun, please do not tell me that that is conduction because your hair is not touching the sun. If that were the case, then your hair would be a whole lot more than hot. You would like burn to death and die. Little extreme, but true. The sun warms us up with its rays. So that's radiation. We don't warm up from conduction from the sun. That would be bad. Alrighty. So remember, radiation, the things are not touching, but heat is still being transferred. Got it? So when you step on hot asphalt, is it because the sun was heating it through conduction or radiation? All right, I saw Elliot. She's right there with me. She said, yes, love it. All right, looking for some other people to be participant. Yes, Laylan, that's it. Radiation, sun's rays. Yeah, Harlem. Yes, Haley. All right, Britton. I see you guys. Okay, loving it. All right, so we're looking here at thermal energy pictures. So thermal imaging is definitely something. Oh, Britton, what are you doing right now? Unmute yourself. What are you doing right now? What are you doing?
Eating.
What are you eating?
I'm having chili. What is it called? Chicklets.
Oh, all right. So is what you're eating warmer than your mouth?
Yep.
Yeah. So how's the heat being transferred? Is it from your mouth to the food or from the food to your mouth?
From the food to my mouth.
That's right, because the food is warmer. Absolutely. Make sure it's not too hot when you eat it. You might burn your mouth. All right, guys. Sun and fire are the major sources of radiation. So anytime we're talking about a campfire or anytime we're talking about the sun's rays, that is always going to be radiation, because if you touch a fire or you touch the sun, you're going to be doing a whole lot more than just transferring heat. You're going to be burning stuff down, having some chemical reactions because it's going to be burning. And we're going to learn more about that this year, and I'm super excited.
Okay. Isn't the sun made out of gas?
Well, kind of. That gets really tricky. It's actually plasma and a bunch of other stuff. So we ain't going to talk about that. But we do know that the sun emits radiation, which warms us without touching us. All right, so just to recap, The warmth you feel when you sit next to a fireplace is due to heat being transferred by radiation from the fire to your skin. Now, the last type of heat transfer, the third and final type, is convection. And when we sing our songs about the different types of heat transfer, I always do convection like this, in a circle. So everybody do convection like this with me. Convection. Hold on, wait. I gotta see everybody. Let me see it. Convection. All right. You can even do it like this. Make a V with your hands. Convection. Convection. Yes. So what happens with convection is that when your water molecules or your air molecules heat up, they become less dense and they begin to rise. And then as they get to the top, away from whatever's heating them up, they begin to cool and become more dense, so they sink. Because we know that warm air rises and cool air sinks, or warm water rises and cool water sinks. So that is what creates your convection current, that warm air or water rising and the cool air or water sinking. That is actually how our houses are cooled. As you can see here at school, can y'all see the air vent? I can't really see it right there. Y'all see it? So what happens is the air comes from the air vent and it works its way around the room through the process of convection. So on hot summer days when the room is hot, the cool air comes out from the vent, it sinks, and then it moves across the floor, and then as it heats up, as it touches all that other warm air in the classroom, it then begins to rise. So as that is happening, there's more cool air coming from the vents, and it creates the cycle of convection, right? Because cool air and water is more dense, so it sinks, and then it begins to heat up and become less dense, the particles spread out, and it begins to rise. And that's pretty much what all these bullets here say. You guys want to take a screenshot so you have that to refer to later when you are explaining your process of convection you find in your house. I encourage you to do that. 3, 2, 1, time's up. All right, so again, this is a process that I was talking about earlier, except this is heat. This is a heating furnace here. So it heats up. Really? Do I need to turn names on? Call y'all out? Don't make me. All right, so this heats up the air around it. As the air heats up, it rises. And then it starts to move across the room in convection current. And then as it gets further away from the heater, it starts to cool. So it begins to sink. And then it moves back over, and then it starts to get warm again by the heater. So it rises, moves, sinks as it gets further away from the heat source. And then as it gets closer to the heat source again, it rises. So it is pretty much just a current or a cycle that goes around and around and around again until all of the temperatures are equal in either the pot or the room that the gas is in. So here we have another example for those of you who like your ramen noodles, your oodles and noodles is what I call them. Any of you who like your noodles and you cook them in the stove instead of in the microwave, or maybe you like mac and cheese, when you cook those noodles, and I did see some people who were who cooked pasta last night. That was their example of convection. You can actually use that same picture. Sorry, that was your example of conduction. You can actually use that same picture and point to what's happening inside the pot because you have water in the pot, and you have convection currents that are happening inside of your pot when you're boiling water. So again, as it gets closer to the burner, it gets hotter, the molecules begin to spread out and rise. As they get away from the heat source, they begin to huddle together. Remember, they're cold like penguins, so then they begin to sink, and then they get to the bottom again and they start to rise. they start to heat up. And you guys know how, like, when you're hot and sweaty, you don't want anybody around you or touching you. That's how molecules are. So they start to heat up, and they're like, oh, get away from me, get away from me. And they begin to rise and spread out. But then when they get cold again, they're like, all right, come on, let's huddle, let's huddle, let's huddle. And they get more dense and they sink. So that is how your convection current works. All right, so just to give you guys a pictorial example before we are done with our science lesson, really quick today, guys. Before this here is what your molecules look like when they are close or when they're away from the heat source. Okay, so as they move away from the heat source, they become more dense. The molecules start to get closer together again, which causes them to fall because there's more molecules in a smaller space. But then when they get closer to that heat source, they begin to heat up and expand again and become less dense, which causes them to then rise. Okay? Does anybody have any questions about your assignment yesterday or what my expectations are for your assignment today? Please keep in mind that I want 2 pictures today. One for radiation, so I should see a sun or a microwave or a fire if an adult is around and there is a fire by chance. And an example of convection. This can happen in water. This is actually happening in the air around you at all of your houses right now. So you can just take a picture of the room, but you've got to find your source of your air. So if you have a window unit, that is the source of the cool air that's coming in and displacing the warm air in your house. Or if you have the vents either up near your ceilings or down on the floor, that is the what starts the convection cycle, and it starts to displace that hot air in the room around you. Okay? All right. Seeing a lot of stuff going on in the chat. I've been neglecting the chat. I apologize. Yes, Ocean. Convection is exactly what makes your noodles go crazy when they're boiling. Absolutely. Looks like they're like dancing in circles. Absolutely. Let's see. Cullen says the microwave is all the versions of heat, and that is no. The microwave is just radiation. Conduction happens when your pot is actually on the burner. Okay? Now, maybe if you have one of those convection ovens that has the fans in the back, that could be an example of convection. So there's another example if you guys have one of those at your house. Ooh, yes, Lee, I like that, like the circle of life. You guys are going to see this year in science that just about every single one of our units has a cycle that goes around and around and around and around. Oh, lovelies, I just didn't want to have to do this. Okay. If you annotate again, I'm going to know who you are, FYI. Oh, yes, Colin, that's a good example. Let's see. Can you do both in the same picture? I'm not going to encourage that, but Ocean, I can trust that if you're going to do it in the same picture, that you're going to be able to have some good explanation as to why it is happening. So your description is going to be very, very important if you try to put it in both of them in one picture. And I will be shouting out some of the best entries and some of the best annotations on Monday. So I'm excited about that. And Cammie asked if you could make a flip grid, and you cannot make a flip grid because I didn't set up a grid for that. However, if you want to record a video, just make sure that your explanation is very clear. Yesterday, Jacaden submitted a video, and I enjoyed it. But please make sure that if you submit a video, because you're not going to have the annotations there, you need to make sure that you are clearly describing the heat transfer process that is happening and how you know it is happening. All right, excellent questions, guys. If you don't have any questions and your name is not on this list, you are free to go. But if you have a question for me, please stay. And no, ma'am, thank you, Naha. That's an excellent question. The picture does not have to be at home. If you guys are at a learning center, see if you can get permission to go outside, take a picture. Radiation is warming up the outside right now. It's happening right now. Convection is happening in the room with you. So definitely, if there's a microwave where you're at, bingo, there you go. Yes, Cammie, yes. Go for it, girl. I cannot wait to see it. Oh, bye, Harlem. You have an awesome weekend too, sweetie. You guys have some awesome questions. If you've got a question for me and you're not just staying for testing, please raise your hand so I can address that very quickly. Cullen, you have a question.
Yeah, for the assignment, so for the people who have testing, do we stay on or can we do our work real quick?
Stay on, please.
And do we have to explain it, like what's happening?
Yes. Just like
Got it.
Just like in the example from yesterday. Good question, though. Ansley.